shall continue with Fourier transform, right? Fourier series. Okay. Oh no, I forgot the files. Oh gosh, where were we? Uh, hold on. How about we use this one? Okay. Did we finish Fourier transform? We didn't finish that, did we? Hold on 1 second. I need to log into another one, I guess. What page was that? Did we that we did earlier? Anyone have any idea? Hello, can you hear me?
Page 23, I think.
23. Okay. Today I'm gonna teach with my iPad. Okay. But 23. We have left with okay. We haven't started half range expansions. Okay. How about okay? Hold on. How do I move this thing? Okay, 23, right? We did this, right? Odd and even functions. Okay, this formula 23 we haven't. Okay, uh, we shall do this. Move it over somewhere. Okay, huh? How come it didn't move? Okay, uh, how come I cannot move this?
Professor, we already finished the page 23, I
23.
think.
Okay, we continue with 24. Okay,
Yeah.
good. All right, thank you very much. Okay, half range expansions. This problem is basically asking you to expand or giving you half of the period, okay, and expand another half of the period. Okay, this one says given that xt equal to t for t between 0 and 1, what is it? When t is 0 and 1 and xt equal to t, this is what it looks like, right? Okay, and they ask you to expand xt to be periodic even functions. Okay, you want to expand it to be periodic even functions. Okay, so basically we need to expand the other half, looks like this, right, to make it even. Okay, that's the first half, and this is the second half. Okay, how about I use the red ones? Okay, the second half it looks like this, and then you make it periodic. Okay, you make it periodic. So we're gonna have like this. One more period. One more period. Okay. One more period. One more period. So this is what it looks like. Okay, now we want to find the Fourier series of these functions. Okay, note here that, okay, this is only the period. In this case is going to be 2 seconds. Okay, period is 2 units. Okay, the half range is 1 unit. Okay, one whole period would be 2. Okay, since it is even, okay, so we says, since, okay, xt is even, okay, we know that bk is going to be 0. Okay, bk is going to be 0 because bk is the coefficient of psi, right? Psi omega naught t, and omega naught t, psi omega naught t is odd function. Okay, so bk must be 0. All you need is to find out what a 0 hat is, okay, and ak. Okay, so we need to find a 0 hat. What is a 0 hat? Oh, by the way, please remind me I need to leave at 11:30 today. Okay. Uh, all right. Please remind me when it's very close to 11:30. Okay. Okay. What is a 0 hat? A 0 hat is 1 over t, right? Integral of xt dt, right? For one whole period t. Okay. So it's like from 0 to t, like this. Okay, is the signal average, right? Is the average of the signals. However, since it's even, okay, since it's even, we can have twice, right? We can have twice the period, and then you integrate just half a period, okay? Just half a period. So in this case, we can have 2 divided by the period, capital T is 2. Integral from 0 to 1, okay? And half a period is T, dt. Okay, since it's even. So in this case, we got what? 2 divided by 2, cancel, is a 1, right? So we just have t squared over 2, t from 0 to 1. So we got 1/2. Okay, what is 1/2? You can see here, it looks like this. Okay, the signal average looks like this, is 1/2. Okay, this is 0.5 at this point. You can see if you take the average of the signals, the average is about 1/2. Okay, this is why a 0 hat is called the AC DC component. Okay, the DC component in this case means, it's a 0 frequency. Okay, and it's equal to signal average of 1/2. Okay, what is a AK? AK normally is equal to 2 over t, right? Integral from 0 to t, xt cosine k omega naught t dt, right? Normally it's equal to this. However, when x is even, right? When x is even, you can integrate just half a period, and this 2 becomes a 4. Twice, right? Multiply by 2. Okay, you multiply by 2. So it becomes a 4. Okay. And this, when you integrate this one just half a period, so this xt just half a period is just t. Okay, and that's it. Okay, that's it. How about omega naught? Okay, in this case t is equal to what? T, capital T period is 2. Okay, and omega naught is 2 pi over capital T, which is 2 pi over 2, which is pi. Okay, so what do we have? We have the integral 4 over 2 is 2. Okay, integral from 0 to 1 t cosine k pi t dt. Okay, at this point, you need to do integration by parts. Okay, integration by parts. Okay, if you let u equal to t, okay, if you let u equal to t, and dv would be equal to what? Uh, dv, oh, I need to move this a little. Okay, move this a little. Okay, If we let u equal to t, dv would be cosine k pi t.
Excuse me, Professor.
Yes,
So where did the little t come from in AK?
in ak. This little t here,
Yes.
this equation xt equal to t,
Okay, right. Yeah.
okay? Mhm. This is given, okay? So we got k pi t dt, okay? Normally we don't need to write the dt, right? Okay. If you integrate, well, or you can write dt, doesn't matter, okay? This one you need to take the derivative, okay? Over here, the u, over the u, you take the derivative. The dv, you take the integral. We use the inverse to means the integral, okay? So the derivative of t is 1. The integral of cosine k pi t is cosine, what? K pi t over k pi, right? Okay. So according to this, we're gonna have what? Uh, this is dv, right? So the two take out the two, okay? And we have u integral of u dv. This is integration by parts. Okay, integration by parts. Okay, so we have u. What is that? U times v. Okay, in other words, this is the u and this is the v. Okay, the top is dv, right? The bottom one is the v. So we got t cosine k pi t over k pi minus integral from 0 to 1, right? V du. Okay, v is this one, right? This is our v. Okay, this is our v, and du is just dt. Okay, actually, it's just cosine k pi t over k pi. Okay, dt. Okay, but remember this one you got to have from 0 to 1. Okay, t from 0 to 1. Okay, but this one, okay, you need to integrate it again. Okay, or you can do by part again. Okay, you could do it again. Okay, you can integrate it again. So if you integrate this one again, we're gonna have, uh, oh, I'm sorry, integral of cosine is not cosine. Integral of cosine is what? Sine, right? Hold on, is sine. I'm sorry, I did it wrong. Okay. So this one must be a sine. Okay, okay, I'm sorry.
I think the t cos k pi t should be sine as well, right?
Oh yes, thank you. Mhm. T sine k pi t. Okay, and then you take the integral of this sine of k t pi t. Okay, so you take the integral again. Okay, what is the integral sine k pi t? Sine of k pi t would be negative cosine, right, k pi t over k squared pi squared. Okay, so this whole thing gonna be negative. Okay, but with this negative, okay, so basically we need to multiply by negative, uh, here and then multiply here. Negative 1 here and multiply here. So we got positive, okay? Negative, negative becomes positive, okay? Cosine k pi t over k squared pi squared, okay? So instead of writing this, okay, I write this one instead, okay? I write positive cosine k pi t over k square pi square. Okay, and instead of this, right, we say it's from t from 0 to 1 for the whole thing. Okay, this is what we do. Okay, we do by integration by parts. Okay, but we can do it by table, this table. Okay, and now you just substitute in the values. Okay, when t is 1, so these two over here, we still got 1 sine k pi over k pi minus when t is 0, which is 0. Okay, plus cosine k pi 1 over k square pi square minus when t is 0, we got cosine of 0. Okay, over, well, you could say over k square pi square. Okay, but doesn't, yeah, at this one you need that, right? How about we write this minus cosine of 0 over k square pi square. Okay, what is sine of k pi? Sine of k pi is 0, right? Sine of pi, 2 pi, 3 pi are all zeros. What is cosine of k pi? Cosine of k pi is negative 1 to the k. Okay, it could be cosine of pi is negative 1, cosine of 2 pi is 1. Okay, so it's negative 1 to the k. And cosine of 0, which is 1. Okay. So simplify this, we got 2 times, this whole thing becomes zeros. So you got negative 1 to the k minus 1 over k squared pi squared. And that's how we get for ak. Okay, and that's it. So over here, b0 equal to 0 because x is even. And this is our a0 hat. Okay, and we factor out the constant 2 over pi square. 2 over pi square is constant. And we got negative 1 to the k minus 1 over k square. Hello? เดี๋ยวอีกตอนสอนปอเสร็จอีกทีก็11 โมงครึ่งแล้วเดี๋ยวใช่นี่เขาอยู่คนละทิศตอนนี้เขาอยู่ที่ซียูเทเลสอ๋องั้นก็เดี๋ยวต้องไปทะลุรัฐศาสตร์โอเคได้จ้าจ้าจ้าใช่ใช่จ้าทำไมเออก็เดี๋ยวไปรับแล้วเดี๋ยวไปรับรอตรงนั้นก่อน Okay, I'm sorry. Okay, and this is actually, oops, this whole thing is actually our AK. Okay, and don't forget to put in cosine k omega naught t. Okay, this one is cosine k omega naught t. Okay, all right. So this is our functions. Okay, I'll delete that. Okay, here this is 0. Okay, and so you write down, okay, for each terms you might want to expand a few more terms. Okay, maybe 2 or 3 terms. Okay, when k is 1, we have what? Negative 1 to the 1, negative 1 to the 1 minus 1. So you got negative 2, right, over 1. okay, over 1. Okay, how about I write out like this? Okay, uh, negative 2 cosine pi t. Okay, this is when k is 1. When k is 2, when k is 2, you got negative 2, any 1 over 2 square is 0. Okay, so when k is 2 is equal to 0. Okay, we don't need to write out the terms. So we need k is 3. When k is 3, we have negative 1 to the third, which is negative 1 minus 1. So we got negative 2 again over 9, right? K is 3, so 3 squared is 9. And cosine 3 pi t, okay? And so on. So we got negative 2 to the what? What's the next term? K is 4 is going to be 0. When K is 5, so it's 25, okay? Cosine 5 pi t, and so on, okay? And that's how we get the series. Okay, we write xt in terms of this cosine series. Okay, Fourier series. Okay, and that's it. Oh my, it's almost 11. Okay, 11:30. I need to leave. Okay, next. All right. Here, let's move all these over somewhere else. Okay. Okay, let's do this one again. Okay, by myself. Okay. Now, suppose we have xt again, okay? Xt equal to t for t between 0 and 1. So this is xt equal to t. But in this time, you are supposed to expand, okay? You're supposed to expand the to be periodic odd functions, okay? You want first, you want to expand it to be odd function. To expand it to be odd function, this is what we have, okay? And then you make it periodic, okay? This is one period, okay? And you make it periodic. We get this, okay? We got this one, okay? So this is our periodic odd functions, okay? Since it is an odd function, what is a zero hat supposed to be? Can you answer it here? Since now, since x t is odd, what is a zero hat? Okay, everyone please answer it to get attendance point for today. Yes, wow, it's so easy, right? Uh-huh. Attendance point for today is so easy. A zero hat will be 0. How about AK? AK is also 0. Okay, that's it. It's so easy. And you can see since it's odd, okay, the signal average is actually at 0. See, this is the signal average. Okay, this is the signal average equal to 0. Okay, so it's 0. Okay, and BK, how about BK? BK, since it's odd, BK is not, right? So BK originally is what? 2 over capital T, integral for one period, capital T, xt, sine k omega naught t dt, right? Okay, but since x is odd, okay, since x is odd, we integrate just half a period, and these two become a 4. Okay, these two become a 4. Okay, and our xt is just t. Okay, xt is just t. Okay, so go ahead and integrate this. What do we have? We got 4. Remember, capital T is equal to 2. Okay, half a period is 1, so the whole period will be 2. So we got 2 integral from 0 to 1 t sine k. Omega naught is 2 pi over 2, which is pi t dt. Okay, go ahead and integrate this. We do the same thing, integration by part. Okay, this is t. The inwards we can be psi k pi t. Okay, t you integrate, you got a one. Okay, integrate, take the derivative again, we got zero. Okay, psi k pi t integral, take the integral, you got negative cosine k pi t over k pi. Okay, and then take the integral again, we got negative sine k pi t over k pi. Okay, and don't forget to put in plus minus and so on, and then you multiply, and the zero, it doesn't matter, you multiply it, you got zero at the end, right? Okay, so you don't really need that because this is zeros. So this is what we have, integration by part using table. Okay, this is what I do. Okay, so I would get,
Professor,
yes.
should the kt of the zero be k pi square?
Oh yes, k pi squared, thank you for the second derivative, integral, right? Yes. Okay, thank you very much. Okay, so yeah, two, these two has nothing to do with integration by parts, so it's outside the parentheses, and we got negative t cosine k pi t over k pi, right? That's for this one. T times negative cosine k pi t over k pi. And for the second one, you got negative 1 times negative sine. So you got positive sine k pi t over k squared pi squared. And that's it, okay? Because the last one is zeros, okay? So this is what we have. And you got t from 0 to 1. Okay, go ahead and do this. What do we have? 2. Okay, t is 1. So you got negative cosine k pi plus, when t is 0, we got 0. Okay, cosine 0 is 1, so we got 0 anyway, k pi. And then plus sine of k pi minus sine of 0 over k squared pi squared. Okay, and what? Sine of k pi is 0, sine of 0 is 0, so the second term disappear. Cosine of k pi is negative 1 to the k. So we have bk to be, what? We got bk to be 2 over k pi times negative, this, there's a negative 1 here, right? Negative 1 times negative 1 to the k, so we got negative 1 to the k plus 1. Okay, and sine k omega naught t. Okay, but remember our omega naught is pi. Okay, so this is what we get for the Fourier series for xt. Okay, and we expand a few terms. Okay, we can factor out the 2 over pi. Okay, and so you got 1 over k, k from 1 to infinity. Okay, k from 1 to infinity. So you got 1 over 1, negative 1 to the, uh, 2, which is 1. So you got psi t, psi pi t. And then minus, right? 1 over k, negative 1, when k is 2, so you got negative 1. So it's negative 1 over 2, k is 2, psi 2 pi t. And then plus 1/3 psi 3 pi t. Okay, minus 1/4 psi 4 pi t, and so on. Okay, this is pretty much it. Okay, this is what we get for the XT. All right, I'll leave you to do homework number two. Okay, there are three homeworks. Homework one, okay, page 26, 27, and 28. Okay, as homework. Okay, I'm gonna come back to, you need to do homework first, okay? Particularly homework three, particularly these problems, okay? Because next time I'm gonna give you the answer, okay? Here, okay, with a different methods, okay? But I want you to do the direct method first, okay? So for now, I'm gonna skip this, okay? I'm gonna do the next one, okay, which is inverse Fourier series. Oh, by the way, for Friday, don't forget to tell me to come back to this one, okay? And I'll teach that, okay? Okay, next is inverse Fourier series. Okay, inverse Fourier series. Remember, the Fourier series is just a bunch of numbers. Oh, oh no, we cannot do that either because it's CK. Oh my gosh, that's the end, right? For practice problem, we should have finished this from next last time. Oh my gosh, you're gonna have so many problems. Oh, oh, wow. A lot of practice problem for free series. Yeah. Okay, I want you to try this one. Yeah, try this one instead. Okay, how about we can find the Fourier series by inspections? Okay, or maybe you should 2 minutes. 20 minutes. Can we talk about that? Well, maybe I'll teach you now. Okay, you can do homework later. Okay. Now let's talk about complex exponential Fourier series. Okay. Fourier series can be represented by A0 hat, AK, and BK. Okay. We can combine all these three into just CK. Okay. A0 hat, AK, and K are real. Okay. But CK is complex. Okay. CK is complex. Okay. Well, originally the Fourier series are real numbers, okay, but today's, okay, we found out that Fourier transform is actually complex, okay, so we're going to change it into complex number. Okay, let's try that. Okay, we start off with xt, which is a0 hat plus summation of ak cosine k omega naught t plus bk sine k omega naught t. Okay, so in this case, what is cosine k omega naught t? What am I trying to do? Oh, I see. What is cosine k omega naught t? We use what? Apply. Okay, what should we apply? Cosine k omega naught t.
Euler formula.
Yes, we need Euler formula, which is e to the k omega naught t plus e to the negative k omega naught t all over 2. How about sine? Okay, actually, this one's supposed to be plus, okay, just plus bk first, right? Plus bk. Sine k omega naught t would be e to the k omega naught t minus, no, actually there's a j there, right? There's a j there. E to the j k omega naught t. Okay, there's supposed to be a j there. Okay, so we got negative j k omega naught t all over. What is all over?
2J.
2j. Okay, I don't like the 2j, the j underneath. Okay, I don't like this j underneath. Okay, I change it into negative j. Okay, so this one becomes negative j, and this j disappear. You see what I mean? Okay, 1 over j is equal to negative j. Okay, this is what it means. Okay, so this negative j here come from 1 over j. Okay, all right, next. Okay, I can combine the terms. Okay, I can combine the terms. Okay, the terms is e to the j k omega naught t. How come there's a t missing there? Right, there's a t missing here. Okay, and the terms with e to the negative j k omega j k omega naught t. Okay, what's the coefficients of e to the what's the coefficient of this one? Well, it's this term, right? And the coefficient is AK and then negative JBK over 2, right? So we got AK minus JBK all over 2, okay? And the coefficients of e to the negative JK omega naught t would be AK minus, there's a minus here, minus minus is a plus, j bk over 2. Okay, yes, you get that? Okay, just combine them, and I call this term ck. Okay, if this term is a ck, I'm asking you, what is this term? Ah, okay, if AK minus JK BK, JBK over 2. Okay, so let's answer the questions. Okay, if, okay, uh, what? E XP of what? I need to remember. If this term is AK, if AK minus JBK over 2. Conjugate, oh yeah, Kevin. Very good. Okay, yeah, okay. Yes, that's what I'm looking for. Okay, yes. Okay, good job. Okay, if this term is called CK, okay, this term gonna be, since it's just change J to negative J, okay, it's just CK conjugate. Okay, so in this case, CK is uh, AK minus JBK, 1/2 of AK minus JBK. And well, hold on. And how come it can becomes this one? Oh, I see. Okay, that's the term. Okay, we're gonna come back to this. All right. Okay. We're gonna come back to this later. Okay, we're gonna come back to this expression later. But at the moment, we have this. Okay, we leave it here for a moment. Okay, now we come back to here. Okay, we say CK is one half of AK minus JBK. Right. So it's one half. What is AK? AK is 2 over T integral for 1T xt. Right. What is this? Cosine k omega naught t dt, right? Okay, that's the AK. Okay, how about BK? So you got negative J, right? This is negative J here, and this is supposed to be BK. Okay, this is supposed to be BK. So what's BK? BK is 2 over T integral for one period T xt psi of k omega naught t, right? Over here, I can take the one half in. Okay, the one half cancel with this, multiply in the parentheses. So we factor out the 1 over t. Okay, integral of xt, and in the parentheses is going to be cosine k omega naught t minus j psi k omega naught t. Okay, how about I use the yellow one, the orange ones. Okay, this one going to be cosine k omega naught t minus j psi k omega naught t. Okay, so we got what is cosine k omega naught t minus j psi k omega naught t. This is Euler again. Okay, Euler again. We have e to the negative j k omega naught t. Okay, this is Euler. So basically, our ck, which is defined as this one, okay, it becomes just this one. Okay, put the stars here because this is the one we want to use. Okay, this is the one we want to use. Okay, and this ck, okay, if what is c0? C0 is when k is equal to 0, which is 1 over t integral for one period xt e to the 0 dt, right? But e to the 0 is 1, which is just the signal average, right? This is our what? What is C0? Okay, go ahead and tell me what is C0. What is C0? It's the 1 over t integral of xt dt. It's the signal average, which is what? Anyone? A0 hat. That's right. Okay. Okay. So C0 is A0 hat. Okay. Now, what is C conjugate negative K? C conjugate negative K. So we put in here 1 over T integral 1 for one period T xt. And then you make the conjugate and make the negative K. Okay, so we got, remember, xt is real. Okay, so it doesn't matter if it's conjugate or not, it's the same thing, and it doesn't depend on K. So in this case, is the if it's conjugate, you change what? J to negative J. Okay, and you want k to negative k as well, omega naught t dt, right? So you can see here, this is the same as ck, right? If you put the conjugate and negative k, it becomes the same as ck. Okay? Yes. Okay, now, so we come back here, okay? We come back here and we change the we come back to this one, okay? We change the k to negative k, okay? This k, okay? Change this k to negative k. So this k becomes negative k, but c of negative k conjugate is ck, okay? And this k from negative k, so k from negative infinity to negative 1 to negative infinity, okay? See that? And this a0 hat is just c0, okay? c0. So basically, if you combine all three terms here, okay, you're going to end up with this one, okay? K from negative, this is the negative part, okay, and that's the zero part, and this is the positive part, okay? So we got k from negative infinity to infinity, ck, e to the plus jk omega naught t. This is we call the complex exponential Fourier series representations, okay? And that's pretty much what we have, okay? And according to this, AK, okay, if CK is 1/2 of AK minus JBK, what is AK? AK would be, what is this?
CK plus CK conjugate divided by 2.
Right, or it's the real part of CK multiplied by 2, right? The real part of CK is 1/2 AK. So AK is twice the real part of CK. And how about BK? BK would be twice negative 2, right? Negative 2 times the imaginary part of CK, right? That's how we get BK, because imaginary part of CK is negative BK over 2. Okay, so BK will be negative the imaginary part of CK. All right, and that's what we have. Okay, for the 11 point, so we have this, and that's how we get the Fourier series. Okay. So we can use Fourier series instead of finding A0 hat, AK, and BK separately. We could find CK just one time, and then we can figure out A0 hat, AK, and BK. For example, find the Fourier series of this function. Okay, since this function is e to the c 3t, okay, CK is defined as this one, 1 over t integral of xt e to the negative jk omega naught t. Okay, so this is 1 over t integrate from 0 to, this is the period, right? Pi. Okay, e to the 3t times e to the negative j k omega naught t dt. What is omega naught? T is equal to pi. Omega naught is equal to 2 pi over t, which is 2. Okay. So we have 1 over t integral, or we can take the integral. We took the integral, we got e to the 3 minus omega naught is 2, right? So it's minus 2jk, the whole thing times t, right? Over 3 minus 2jk from t from 0 to pi. Okay, t is pi. Okay, t is pi. So in this case, we got 1 over pi e to the 3 minus 2jk pi minus t equals 0 is 1. E to the 0 is 1. So we got 3 minus 2jk. Is that right? Okay, what is this? How can we find a0 hat, ak, and bk? Okay, this one we got 1 over pi e to the 3 pi times e to the negative 2 pi j k, right? 2 pi j k minus 1 over 3 minus 2 k j2k or j2k, j2k. Okay, e to the 3 pi is nothing, it's just a number, but e to the, remember, k is integers. Okay, k is integer. So this is e to the multiple, integer multiple of 2 pi j, okay, which is 1, right? Multiple integer of e to the multiple is equal to cosine 1, 0, which is 1. Okay, this whole thing is 1. But this one there's a multiple, so I multiply to make the denominator real number. We multiply by 3 plus j2k divided by 3 plus j2k. Okay, I'm gonna get what? E to the 3 pi minus 1 over pi. That's a constant. Okay, and multiply by 3 plus j2k. And these two terms multiply together, we got 9 plus 4k squared. Okay.
Professor, sorry to interrupt you, but you asked us to alert
Yeah,
you
11.
at
Okay.
11:30.
Okay. Thank you. Thank you. Thank you. We finished this. Okay. It's 4k squared. Okay. Hold on. 4k squared. Okay. So that's it. That's our ck. Okay. And then you can find out a0 hat. Okay. You can find out a0 hat, ak, and bk from here. Okay. Remember, ak is twice the real part of ck, which is e to the 3 pi minus 1 over pi 3 over 9 plus 4k squared. Okay, and twice, so it's 6, right? Okay, twice the real part. Okay, and a0 hat is just c0. Okay, c0 is just what? E to the 3 pi minus 1 over pi times 3 over 9 over 9. So it's 1/3, right? So it's divided by 3 there. Okay, and for bk, you can get what? E to the 3 pi minus 1 over pi, and twice times the negative. So it's times negative 4k over 9 plus 4k squared. Okay, that's how you get the imaginary parts. Anyway, okay, I'll leave you to here. Okay, I need to go now. Okay, thank you very much, everyone, for paying attentions.
อาจารย์ครับ
Yes,
according to the syllabus we will have a quiz next week. Do will we have a quiz or
yeah,
you will postpone?
yeah, we can have a quiz next week because we finished for your series. Okay, we're gonna have one more time on review of the Free series on Friday. We can have the quiz next Monday. Is that right? Yes. Yes, we will. Thank you.